Q5114. What altimeter setting is required when operating an aircraft at 18,000 feet MSL? A. Current reported altimeter setting of a station along the route. B. 29.92 inch Hg. C. Altimeter setting at the departure or destination airport. The correct answer is B. When operating an aircraft at 18,000 feet MSL, mean sea level, the altimeter setting that is generally required is B. 29.92 inch at altitudes above the transition level, which is typically around 18,000 feet MSL. Pilots are instructed to set their altimeters to a standard pressure setting of 29.92 Hg. This is referred to as the standard setting or flight level setting. It allows for a standardized reference of altitude based on the International Standard Atmosphere, ISA, and ensures consistency among aircraft operating at higher altitudes. 5408. An airplane is located at an airport with an elevation of 5,000 feet MSL and a temperature of 90 degrees Fahrenheit. The altimeter is set to airport elevation. Later that night, the temperature plummets to 50 degrees Fahrenheit. Unless the altimeter setting is changed, it will read A. 4,800 feet, B. 5,000 feet, C. 5,200 feet. The correct answer is C. A drop in air temperature will cause the air to become denser and lower the density altitude of a particular airport. The altimeter will read higher than the field elevation if the altimeter setting is not adjusted for the change in pressure. 5178. Which statement is true about magnetic deviation of a compass? Deviation? A. Varies over time as the atomic line shifts. B. Varies for different headings of the same aircraft. C. Is the same for all aircraft in the same locality. The correct answer is B. Magnetic deviation refers to the error in the indication of a magnetic compass caused by the magnetic fields within the aircraft itself. These magnetic fields can be generated by various components such as the engine, electrical systems, or ferrous materials on board. Deviation can vary for different headings of the same aircraft because the magnetic fields and their effects on the compass can change depending on the orientation of the aircraft relative to the Earth's magnetic field. As the aircraft's heading changes, the magnetic deviation can also change, causing the compass to provide slightly different readings. 5268. What is an operational difference between the turn coordinator and the turn and slip indicator? The turn coordinator? A. Is always electric. The turn and slip indicator is always vacuum-driven. B. Indicates bank angle only. The turn and slip indicator indicates rate of turn and coordination. C. Indicates roll rate, rate of turn, and coordination. The turn and slip indicator indicates rate of turn and coordination. The correct answer is C. The turn coordinator and the turn and slip indicator are both flight instruments used to indicate the aircraft's turning performance. However, there are operational differences between the two instruments. The turn coordinator provides information about the roll rate, rate of turn, and coordination of the aircraft. It typically consists of a gyroscope that senses the roll and yaw movements of the aircraft. The turn coordinator displays the rate of turn with a needle or a symbolic aircraft representation. It also indicates coordination by using a ball or similar indicator to show if the aircraft is coordinated or slipping/skidding. On the other hand, the turn and slip indicator, also known as the inclinometer or the needle and ball indicator, primarily indicates the rate of turn and coordination. It uses a needle or a ball to show the rate of turn and the coordination of the aircraft. It does not provide direct information about the roll rate of the aircraft. 5269. What is an advantage of an electric turn coordinator if the airplane has a vacuum system for other gyroscopic instruments? A. It is a backup in case of vacuum system failure. B. It is more reliable than the vacuum-driven indicators. C. It will not tumble, as will vacuum-driven turn indicators. The correct answer is A. In an aircraft equipped with both an electric turn coordinator and a vacuum system for other gyroscopic instruments, the electric turn coordinator can serve as a backup in case of a vacuum system failure. The vacuum system is responsible for providing power to gyroscopic instruments such as the attitude indicator and heading indicator. If the vacuum system fails, these instruments may become unreliable or inoperative. However, the electric turn coordinator operates independently of the vacuum system. It is powered by the aircraft's electrical system, typically utilizing solid-state gyros. This means that even if the vacuum system fails, the electric turn coordinator can continue to provide accurate information about the rate of turn and coordination.